For this question, we're looking at an example of an exponential growth and decay problem. So we have an automotive company purchases new robotic welding equipment for $28.6 million. The value of the equipment will be depreciated at a rate of 15% per year. Write an equation for a function v that gives the value of the machinery after t years. So what we're looking at here is depreciation. Well, if we're looking at depreciation, then that means that we have a decrease. It's decreasing at a rate proportional to itself, so that means that we have an exponential decrease, exponential decay. So if we want to figure this out, we first need to figure out a formula. It's asking us to write an equation. And it's giving us v after t years. So it's going to look like v of t, our value after time. But we need to figure out what it's going to represent. So we're decreasing by 15%. So we were at our original 100%. It's going down. It's going down by 15% per year. So that means that it's going to leave us with 85% of the original value for each subsequent year. Changing that to a decimal would give us 0.85. So if we start with our original value of 28.6 million, and we multiply it by our 0.85, we would do this year after year after year after year. So we can raise it to our exponent of t. And the units would be millions, so we'll just write that this will be in millions. So there we go. Now we have an equation that is modeling our depreciation of our welding equipment over time. So now it's going to say how long will it take for the equipment to reduce to half of its original value. So we're looking for our value at our time to be half of our original value. Well, our original value was 28.6 million. So if we're looking for half of that original value, 28.6 million divided by 2 is 14.3 million. So now we're trying to figure out when will v of t be 14.3 million. Well, we can figure that out because we have our equation right here, and now we know our v of t value. So if we have our equation and we know our v of t value, we can substitute it in. So 14.3 is equal to 28.6 times 0.85 t. Now we need to solve it down. So in order to solve this down, the first thing we should do is divide by our 28.6. We're trying to get the t, so we need to move everything else away. So this is going to leave us, we can convert it to a decimal. That's okay. But if we do our division, it's going to be a half. So we can do a half equals 0.85 t. Now this is where it gets tricky. In order to get, this needs to be an exponent of t. There we go. In order to get the t from the exponent, we have to use what's called the natural log. The natural log of 1/2 is going to be equal to the natural log of 0.85 t. And the beauty of the natural log is it lets us get this t out of the exponent. So this will become the natural log of 1/2 is equal to t times the natural log of 0.85. Natural log is a key on your calculator. So if you type in ln on your calculator, there's a button. Usually it's with the same button as e raised to the, or sometimes it looks like e to the x. But there should be a button on your calculator for natural log. So depending on which model of calculator you have, you'll have to type it in a couple different ways. So what you'll want to do is type in the natural log of 1/2, and then you're going to divide that by the natural log of 0.85, so that we're left with just t. See right here, divide ln 0.85, divide ln 0.85, and make sure you're typing it in correctly. Once you type it in and you solve it down for t, you should get approximately 4.27 years. So we have to be careful to type in our natural log. Part C, Compute and interpret v prime of 5. Well, the first thing that we need to do is figure out what that's going to mean. So what is v prime of 5? Well, the v prime means the derivative, and the derivative means the rate of change. So this is going to be the rate of change after our time of 5 years. So let's see if we can figure this out. So let's start at our original equation. So we know that we have v of t, and that is equal to 28.6 times 0.85 raised to the t. Now, in order to take this derivative, we have a product rule. We have a first right here, and we have a second right here. This is also a constant, so you can think of it as if it were a constant being multiplied, and that will work as well. Because if you think of it as a product rule, when you do the second times the derivative of the first, the derivative of 28.6 is 0. So you can think of it either way. You can think of it as a constant multiplier in the front. You can think of it as a product rule. It will work either way. We also need to make sure that we're remembering our formula for the derivative when we have the exponent. So if you have a to the x, then that derivative goes to a to the x times the natural log of a. So we're going to need to use that one for this derivative. All right, let's try this. So we have v prime of t. Remember, you can't substitute the 5 in until after you've taken the derivative, because we need the rate of change, not the value at 5. We need the rate of change at 5. So we have the first, so that's 28.6. times the derivative of the second. Well, the derivative of 0.85 to the t is going to look like 0.85 to the t times the natural log of 0.85. And that's from our natural log derivative formula right here. And then when we do the second, we'll have that 0.85 raised to the t times 0. So this whole piece is going to cancel away. So you don't need it. And we can clean up a little bit. All right, now let's keep going. We're told that we want v prime of 5. So wherever we see our t, we're going to need to put in a 5. Raised to the 5th. There we go. And now we can type this into the calculator. Typing it in gets kind of tricky, so double check when you type it in, make sure you're typing it in correctly. You're going to need to use some parentheses. So you would type 28.6, then put it in parentheses, 0.85 raised to the 5th. You'll have to use your exponent key that looks like this. Sometimes it's a key that looks like this, depending on what calculator you have. And then you'll need to have your natural log and your 0.85. When you type it all in and equal it out, it should be approximately negative 2.06. Now it's negative because it's decreasing. So that means that it is going down. So that makes sense. The value should be going down if it's decreasing. So what does this mean? This means that the rate of decrease at a time of 5 years is about $2.06 million per year. There we go. Part D, when will the value of the equipment be decreasing at a rate of $1 million per year? So now we're looking for what time will give us a rate of decrease of $1 million. Now it's a decrease, so let's do negative right here to show that decrease. Everything's in millions, so we're okay. So $1 million will be our negative one right here. So let's figure this out. So we have our negative 1 going back to our original equation. So our original equation said v prime of t is equal to 28.6 times 0.85 t times the natural log of 0.85. So now we're trying to figure out what t value should we use to get us -1? It's not asking us what the value is after a time of 1. It's asking us when the value is going to be $1 million decrease. So we're asking when the rate will be decreasing at a rate of $1 million per year. So let's see if we can figure this out. We need to solve for t. T is right here. So that means that we need to divide the 28.6, and we need to divide the natural log of 0.85 by both sides. So that's going to leave us with -1 in the numerator, 28.6 times the natural log of 0.85 equaling 0.85 raised to the t. So when we simplify this down, let's go ahead and type this into the calculator. You're going to need to use parentheses again. You need -1 divided by, open a parenthesis, do your multiplication, and then you should get approximately 0.215 is equal to 0.85t. In order to get the t out of the exponent, we need to take the natural log of both sides. Once we take the natural log of both sides, I'm running out of room. I'm going to continue over here. Once we take the natural log of both sides, we'll be left with the natural log of 0.215 is equal to t times the natural log of 0.85. Divide both sides by your natural log of 0.85. Make sure you're typing it into your calculator right. So you'll need your natural log of 0.215, and then you'll need that divided by the natural log of 0.85. So when you do that, you should get 9.458 years. Pushing the buttons on the calculator can get pretty tricky for this one. So double check your calculator, make sure you are understanding how to enter everything. And if you have any questions on that, don't hesitate to reach out.